Okay, in this video we will be talking about the first derivative test. We are going to be doing numbers, let me check, 44, 70, 81, and 85. The reason I have 81 and 85 highlighted is because, asterisk, is because you're not actually going to be tested on those in the buddy quiz, but I'll do it anyway. Here's 44. It says find the open intervals in which the function is increasing or decreasing. Okay, and this looks like a no calculator problem, so let's go ahead and take the derivative first. Okay, f prime of x is equal to, this is x over 2, which is 1/2 x, so the derivative of 1/2 x is just 1/2, minus sine of x, and that's the derivative. So now I need to find out whether the function is increasing or decreasing, which means I need to set f prime equal to 0. I notice that this function is defined everywhere, so I don't need to look where f prime is undefined. So f prime equals 0 will be my critical numbers, so let's go set f prime of x equal to 0. And I end up getting out 1/2 equals sine of x. Now in the unit circle, sine is equal to 1/2 at, sine is the y value, so I believe it's pi over 6, and I believe it's 5 pi over 6. Okay, let me do the line test to make sure that I have increasing and decreasing. So here's pi over 6, here's 5 pi over 6. This line test name is f prime. On the left of sine of x, I have, let's see here, like sine of 0. Sine of 0 is 0. That's the positive value. And on the in-between pi over 6 and 5 pi over 6 is something like, what interval am I on? 0 to 2 pi, okay. Something on the right side of pi over 6, something like, oh, that should be a positive. Like pi over 2. So sine of pi over 2 is 1. 1/2 minus 1 is a negative number. And then sine of something like pi is 0 again, so that's 1/2. Which means that this value is going to be positive. Sorry, I'm not paying attention here. Okay, so this tells me that f is increasing on the interval from 0 to pi over 6. E union 5 pi over 6 to 2 pi. F is decreasing on pi over 6 to 5 pi over 6. I can tell this because f prime is negative on that interval, and for increasing, f prime is positive. Okay, so I got A taken care of. Let's take care of B. Apply the first derivative test to identify all extrema. So the extrema that are around here are going to be, at pi x equals pi over 6, f has a relative max. The reason I know this is because f prime changes from positive to negative. And I'm not going to write that down, but it's important that you guys recognize the justifications for these statements. F has a relative max because f prime changes from positive to negative. And at x equals 5 pi over 6, for a similar reason, f has a relative min. And these are both by the first derivative test. Okay, let's use the graphing calculator to confirm the results. Okay, let's see here. Let me get a graphing calculator here. Let's see here. Sorry I didn't have this ready beforehand. I just didn't think I would actually need it. It's loaded. It's validating the software license. I'm not using it illegally for those of you that think I am. Okay, here we go. Where is it? Oh no, I can't do it because I'm not at school. Okay. Well, when all else fails, let's go to Desmos. Did I have that right, guys? I hope. Where I need on the interval from 0 to x is less than. See that the function has a max at pi over 6. And also from 5. So everything that I did with next one. But first I need to adjust my graphing window. Because this is all crooked now. Okay, here we go. There we go. That feels slightly better. Let's do the next one. Okay, identify critical numbers. Okay, we got this. This is for number 70. Oh, but this is graph of f prime. Oh boy. Okay, when you're given the graph of f prime, please make sure you take a second to just think about it for a minute. So critical numbers of f based on f prime would be where f prime equals 0, so roots. Okay, so here x equals 2 is a root. I'll do all these in black. On this graph, it looks like x equals 0 and 1, because that's where f prime has x-intercepts. That's where f has critical points. On 3, x is equal to -1, 0, and 1. And on 4, x equals, it looks like -3, 1, and 5. And again, the reason f prime equals 0, I'm looking for zeros here. Okay, second, where f is increasing and decreasing. Okay, this one is going to be 2 to infinity. This one is going to be from -infinity to 0, union 1 to infinity. This one is going to be from -infinity to -1. Now the reason I know this is I'm looking everywhere that the f prime graph is above the x-axis. So union looks like 0 to 1. And for this last one, it looks like it's -3 to 1, union 1 to 5. Okay, that's where f is increasing. Decreasing. So decreasing is where f is going to be, decreasing is where f prime is going to be under the x-axis. So on this first graph, -infinity to 2. On the second graph, 0 to 1, because that part is where f is underneath the f prime is underneath the x-axis. For this next one, it's going to be negative 1 to 0 and 1 to infinity. And for this fourth one, it's going to be from negative 3 to negative 3. Union 5 to infinity. Okay. And again, the reason I knew that is this is where f prime was underneath the x-axis. Oh, okay, let's try that again. Beneath x-axis. And again, this one, f prime is above x-axis. Okay, to find max and mins. So wherever f prime changes from positive to negative, I'm going to type this for you guys. Wherever f prime changes from positive to negative, E. Third graph is going to be at x equals 3, negative, and 1, because that's where f prime changes from positive to negative. And on this graph, it's going to be at x equals, let's see here, only 5. Come on. Okay, the min is going to, relative min is going to occur at x equals, on this one it's going to be x equals 2, because f prime changes from negative to positive. On the second graph, it's x equals just 0, 1, because f prime changes from negative to positive. Here, on the third graph, it's going to be x equals 0 only, because that's where f prime is underneath the graph and goes above the graph, above the x-axis. And then on this graph, it's just going to be at x equals negative 3. And that's it for this problem. Oh, that's a lot of work. Okay, number 81. So remember, not on the buddy quiz. So please don't feel obligated to do this. Okay. Find the velocity of the particle at any time t is greater than or equal to 0. Velocity is just f prime. Identify the interval. This is where f prime is positive. This is where f prime is negative. The reason I'm not going to explain this that much is, number 1, you're going to learn it in a couple weeks. Number 2, it's not on the buddy quiz, and I just want to get these videos done. The time at which the particle changes direction, that's where f prime changes signs. Okay, so let's take a derivative here. V of t equals 6 minus 2t. Let's set this equal 0 to see what's happening here. It looks like t equals 3. So let's do a line test on 3. Let's just call v of t. On the left of 3, like 2, we have a positive value, and then we turn negative. Okay, so that was everything for a line test, for v of t, etc. So now let's go and answer the questions one by one. For A, we have anytime t is greater than or equal to 0, from 0 to 3. For B, the particle is in a positive direction. Oh, I'm sorry, hold on. For A, is actually this. This is the velocity at any time t. And then for this part, I'm just going to rewrite this so that way it's color-coded correctly. Okay, and then for b, to find the time intervals in which the particle is moving in a positive direction, that's where f prime is positive, and the velocity here, the first derivative, is positive from 0 to 3. So for b, it's going to be from 0 to 3. It is technically closed at 0. We don't take off if you have the wrong bracket or parentheses. For c, negative direction, well, that's just going to be from 3 to infinity. And I don't think they put an interval on this, so yeah, 3 to infinity. And when the particle changes directions, that's going to be right at the critical point at t equals 3. And again, that's where v of t changes signs. So I'll just write that down for your reference. And let's do one more just like this, and that'll be the end of this one. Okay, so for this one, we have the graph shows the position of a particle moving along the line. Describe how the position of the particle changes with respect to time. So again, this is not going to be on your test. We're going to go over this in the next unit. But let's just say to describe it, particle moves. Actually, I'm going to type this because it's going to be easier to type. But I will highlight the parts. This part is particle moving forward. This is particle moving backward. Right here. And this is where the particle is moving forward again, and then moving backward, and then moving forward again. At these purple points, actually I'm not going to type this, at these purple points, this is where the particle is staying still, that the particle is not changing at all, just for an instant. And then finally, this is where the particle is moving east, or rather is east of where it is currently, still east of where it is currently, and over here it is going to be west of where it is, and then here is east of where it was, and over here is west of where it was, and I think for that last little part is east of where it was. So let me color code everything so that, and type everything so that way you know, because that is very confusing. Okay, let's start with purple. Let's change the font here. Okay. Yes. I hope this helped. It will be 3.4.